Hello everyone, I am Pushpita Chanda. Uh, Hello everyone, I am Pushpita Chanda. I am a PhD student at IIT Delhi and University of Queensland, Brisbane. So I am a TA for this session, Newtonian mechanics with examples. So let us start the session. First, I want to start the section with some example of for degree of the freedom. So for just want to tell the basic examples and how much degree of freedom of these systems have. So these are kind of joints. Have known kind of pin joints in the truss or framework examples. These are different kind of joints. This joint is called revolute joint. So in this joint, this thing only revolve in theta direction. So it can only move in theta direction, no x or y direction movement. So the only independent coordinate is theta, which is we have only one independent coordinate. So degree of freedom for this revolute joint is 1. This is joint. So in prismatic joint, it doesn't rotate. It just can go out and go in. So the movement is only in one direction. We can call it in delta x direction because it is moving in x direction. So only one independent coordinate is here, which is x. So for this system, degree of freedom is also 1. This is helical joint. So basically this and this rotate in the same direction, delta theta direction, but the rotation is indifferent. This revolute joint rotate in anti-clockwise direction, and this helical joint rotate in clockwise direction. Also helical joint can we can make a helical joint which rotate in anti-clockwise direction. Whichever is the direction, only one the independent coordinate is there. So for helical joint also the degree of freedom is 1, and this is called cylindric joint. So in cylindric joint, what happened that the joint can move in x direction also. It can go in and go out, and also move in the theta direction also, so that it can rotate also. So it can rotate and translate also. So here two independent coordinate. So degree of freedom here is 2. And this is a diagram of spherical joint. So in this joint, the joint moves in three direction. All are angular direction, but like x, y, and z direction, they move in three angular direction. If they move about this axis, so here they call this like it can move like this. So it's say they denoted it as a delta theta direction. Also, it can denote about this axis also. They call it as a delta phi direction. And also, this joint can move along this axis. Move along this axis means this axis will remain same. All other things will rotate. Move along this axis means this axis will remain same and all other things will rotate. So the spherical joint can rotate about three axes. So they have three independent coordinate, although all are axial coordinate, but they had three independent coordinate. So degree of freedom here is 3. And this is called planar joint. Planar joint, it can move in x direction, in y direction, also in angular direction, phi direction. So here also degree of freedom is 3. It can translate in two direction and rotate in one direction. So these are all called uh, joint. And there is another kind of joints. Excuse me. These joints are called pull joints. So there is two different kind of joint, rotating full pin and translating full slider. So rotating full pin, in this rotating full joint or full pin, this portion move about this point only in one direction, delta theta. And in translating full slider or joint, uh, translating full slider joint, this thing only move in x direction. So these are called full joint. One is rotating full pin joint and another is translating full slider joint. Both of these move in one direction. So here degree of freedom is 1. Kind of joint is this. Called roll side joint. So it is also called half joint. This is so this thing is linked against the plane. So this handle also go from this 0 degrees to 360 degrees. So it is an angular kind of direction. They move in angular direction, and also it also moves. This point also moves on the plane. So it has both delta theta and delta x kind of direction. in movement. Here also in cylindric joint you see that it has delta x, the movement in delta x and also in delta theta, and here also we see that there is a movement in delta x and delta theta. They are different kind of joints, they act differently, but they have same kind of degree of freedom. So all of these have degree of freedom too. Here this point moves in a delta x direction, and also this lever moves in delta theta direction, so whole joint moves in delta x and delta theta direction. And here the pin in slot, the slot in delta x direction, you can see that, and this pin can move in delta theta direction. It is these two joint, one is called first order pin joint, is called second order pin joint. So here you can see that this is a link reference, and there is a like another lever which can move in delta theta direction. So 1 degree of freedom. So the degree of freedom is for 1, and here there is reference and two another lever. So this L2 can move in one direction, delta theta, and L3 can move in another angle, delta theta. Let us call it delta theta 2, it is called delta theta 3. They can move in same angle also, delta theta 2 and delta theta 3 can be same, but they can be different. So they are independent, like whatever value delta theta 2 can be, it will not impact whatever value delta theta has. If there is no restriction, then it will not affect. So basically it has degree of freedom of 2. And this is called planar pure roll side joint. As many, let us move it into the next page. It's not moving. Let me write it here only. I can move it. this can call planar, pure roll, or R, pure slide. RP joint. So here, it can roll or slide, or roll or slide. Depending on that, its degree of freedom will be 1 or 2, when it will roll and slide also. When it will roll and slide also, the degree of freedom will be 2. But if it only rolls, then also degree of freedom will be 1, that only delta theta will change. And if it is sliding only, so delta x will change. So then also the degree of freedom will be 1. Roll or slide, degree of freedom will be 1. So I told all this kind of join basically to let you know that many joints can look very complicated or some very busy kind of thing, but basically you need to know how these levers are working. Joint is one, you can say it is one kind of lever, so in which direction the things can move, right? So in pulley, professor already told in class that if the length, if not if in pulley is the length, this length, if we can say this is x2 and this is x1, uh, if this m1 goes up and m2 goes down, we can think that two independent movement is there, but it is not, because in pulley x1 in x2 is equal to L. So there we have put a constant there, only one degree of freedom here, same as if pull that. But here, for here it is degree of freedom is 1, because all the movement is in one direction, although it is in y direction, but we have noted it as x1 and x2. Yeah, if we consider this kind of pulley, here also if we call it x1 and this x2, here also x1 plus x2 is equal to L. But this is theta 1, this is theta 2. Movement of n will only, like, this movement will be depend on these angles also. So here two different angles, so degree of freedom will be 2, and L is always constant. So they here degree of freedom will be 2, because it is not moving in one direction, it is moving in this direction, so it has component in x direction and also in y direction. So you can say the degree of freedom are x and y, or r or theta. So always remember that how how the system is moving, how many uh, how many coordinate you need to describe a system. So that is how you can like know which degree of freedom is there. Like if there is a 2 point is joined here is different kind of thing and thing, and if you like push this push or pull, this length are all same L. So basically this angle is changing, theta is changing. So although this system looks very complicated, ultimately nothing is in this theta. So theta is only independent. The freedom will be one. Now let us go into some trust problems. So first example, the problem is given in your quiz. So I'm not going to solve it. I'm just give you some hint. So already professor has like explained a little bit of this problem in one of his class, that first of all we need to consider, just change the red thing, the tension here E, and also at E point there will be like a force, like point interaction. So we can like assume that it has a x direction, it has a y direction, Vy. So first step is equilibrium condition of all truss. At point E. all external, like equilibrium condition, consider all external force. Then draw a body diagram for each connecting pins. And already, like, he has given the order. First consider A, then B, then C, then E point again, then D. So let me write first step is to write all the external forces at D and E. Compute all the external forces at D and E. For that, the diagram will be like this. Like here is a tension T. Although it is 90 degree, it is 30 degree x-axis and this is 60 degree. And for Ex, this is the direction. Ey, this is the direction. Here 20 kilonewton in one direction, 30 kilonewton one direction. So first all the torque should be 0. That is summation of E should be 0. Then force balance equation, Fx should be 0. This is torque balance equation. And if y should be 0. For torque balance, okay, we are like calculating torque balance from the point of E. So from the point of E, what are the torque? Five meter. This is 5 meter. This is also 5 meter. So these two are in one direction and this is in another direction. Whatever actually the torque equation are scalar vector product, vector cross product. So if we put all these things in a vector notation, the direction will be taken care of. I'll show you some examples where we write the torque equation in terms of vector equation. Here you can see that this point is 5 meter away from this point E. So 5T minus 20 kilonewton, which is in also 5 meter direction, minus 30 kilonewton, which is 5 plus 5 10 meter direction, equal to 0. So I am writing kilonewton to know that T we will have, that is will be in kilonewtons. So E will be 20 into 5 plus 30 into 10 by 5 which will be 80 kilonewton. And Fx is that like is excitation component or excitation component. This weight doesn't have any x direction component, so Fx will be, so E is here. So here the system is this truss. So we are like calculating the external, computing the external force uh, acting on truss. No, truss is not not dx on this joint, but from this point dx is direction. So we can say it is negative x direction, and dx component is positive x direction. So we have gotten T. So 80 kilonewton cos 30 degree minus Ex is equal to 0. And Y will be 80 sine 30 degree. So this will be Ty direction, which is 80 sine 30. So minus 20 minus 30 plus Ey direction is equal to 0. So from here we will get Ex, and here we will get Ey. Now we need to know about joint A. So AB in this direction, when we joint A. So AB is in that direction. Is C is that direction, because the AB that this direction for joint B, so D works in this direction, AB this direction, B this direction. This is 60 degree, this is 60 degree, 60 degree. So we need to write force balance equation for each of the point. Let me write for joint 1. From joint B, we will write and solve each. Like the question is to compute the force in each member of the loaded cantilever truss. So by that for A to count to Fx is equal to 0. So it will be AB of 60, sorry, of this 90. So this will be AB cos 60 degree, which will be half. So if minus AC will be 0, and for Fy will be AB sin 60 degree minus 30 equal to 0. From here you will get AB, and when you put the AB in this equation you will get AC. Now when you get AB here, for joint B write Fx is equal to 0 for balance equation, and Fy is equal to 0. Put AB value in this thing, you will get the value of BC and BD. C join C see what will be the BC, what is AC from joint A, and you need to know here CE and CD. When C free body diagram is that. So if we put Fx is equal to 0 and Fy force balance equation in x direction and y direction, you will get what is CD and what is CE. After that, you need to come to the joint E. The conditions are in E. So in this direction, E is EY. You know the value of EY. And this is BE. This is CE. You will get from here what is CE value. And this is EX. You will also get EX from this equation. also, you need to equate fx equal to 0 and fy equal to 0. You will get dE. So all the if we solve all the pinpoint, you don't need to go to till point D, because if you get D, solution is solved almost. So just from here I can give you what is Ex. Ex almost is 69.8 kilometer. After that you need to solve. I have already written uh, the x and y force balance equation for joint A. From joint A, you get AB and AC. From joint B, you get BC and BD. Then put the value AC and BC here for joint C, and you get value CD and CE. When you get CE value, so in for joint E, all the value you have known. You know value of EX, you know value of EY, you know value of CE, and this angle you also know. This is 60 degree. Just now equate the x force balance. Just write force balance equation in x and y direction for all this four joint. The solution is there. Now the truss is here. Pin joint. No, A is pin joint. B is kind of proper. So this is B. This is C. All the beam are of 5 meter. now, like, to know the forces acting, first we need to determine external reaction first, then internal reaction. So for this, so this call will end soon, like in 10 minutes, I guess. So I have already given the video link for the second half, second hour, here in the message box. Please join via that link. This is so this is the rocker kind of join. Already professor has discussed what we need to do. This is being joined. So for rocker join, we cannot have a dx and dy both, because if we have a force in dx direction, then it will move. But this is all the problem we are discussing. This is like static problem. So we don't want this d to move, so we will only have dy. So we assume that dy is in direction. Similarly, y will be in direction, and let's assume ax in positive x direction also. Okay, so all the external reaction or interaction we want to write in respect to point A. So force balance equation in direction of fx is equal to A will be ax. There is no the thing also I forgot to put forces here. Then Newton, Newton. X. There is only X and 10 Newton. So it will be 0. So Ax is equal to 1. Although we have assumed that Ax in positive direction, but it is actually negative direction. So now we have to write force balance equation in y direction. And so y direction we have ay as a minus and minus. So here, like, so that's the equal to 2. So the another equation to basically basically know what is the component of AY and DN. So this will make a line solution. So this is kind of in the direction of from A direction. AY on AX will be 0 because it's going to dy is 1 meter. This 10 Newton is also 5 meter. Line of action of this 10 Newton also direction 5 meter. This is also 5 direction. We need to line of action through A. Give us this 10 Newton, this 10 reverse. So it will be 10 into minus 10 into 5 plus d1 into 5. From here we get y when we put dy is equal to 20, ay is equal to 0. So we get ay is equal to 0, ax minus 10, dy is 20. Now we need to consider the internal forces. So to consider joint A, B, C, D separately. First, complete the diagram in what kind of forces are acting. A, B, C, D. So this was all given. This is also given. And dy is in this direction. And x is so let us know at each point how many like forces are working. So this is AB. So there is tension. So AB tension work like in this direction. So at point A, AB will like act like this. Already there is 10 Newton. So AC, there is also in AC tension in ACB. So we need to consider the B. There is tension in AD also. So equal and opposite. So in each beam there is tension here. So for D also, dy is in this direction 20 Newton. This is AB, this is CB. For B, here it is B, then In BCD, we also got tension. So it is BC. And also this is perimeter. Here also we get CB, BC point, and in direction to Newton, this direction, 10 Newton. So for joint B, we get equation R where A, B, C, B, into Newton. So if we compute Fx, which will be ATX 0, which is AD will be 0. Now consider joint B. Compute force balance equation for direction. So CB plus 20 divided by 0. So C minus B. So this is direction. BC equal to 0, and for F direction, Y direction force balance equation will be minus AB minus 10 is equal to 0, so AB is equal to minus 10 as well. For joint C, C is 10 Newton. So Newton, this is BC. BC is already 0. So we can remove that, or you can write it here. This is equal to 0. This is AC. This is AB. So BC is equal to 0. So we need to write force balance equation x direction, which will be equal to 0. Force balance equation in y direction, which will be equal to 0. So x axis minus minus AC cos 45 degree plus 10 is equal to 0. We know BC is equal to 0, so AC is equal to 10 by cos 45 degree, which will be 10 root 2 Newton, which is 14.14 Newton. Now we need to write it in y direction. In y direction, is minus 10 minus AC sine 45 degree minus CD equal to 0. So we have already got CD is equal to minus 20 Newton. Let us see from here if we get the same thing. So minus 10 AC is 10 root to sine 45 degrees root 2 is equal to CD. So we get CD is equal to minus 20. So we have CD, AB, AC, so we need calculate or like x and frequency equation about the combination of A, which can get A, which is AB, and AB, we all have already computed AB equal to 0, AC is 10 root 2, and AB is minus 10 Newton. So we have already like computed all the forces in the truss. So now move to question number 2, a different kind of truss. Before that, this call will end in a minute. Please join the second via second link. point contact. This is rocker. G. 5 meter. There is a force acting on A and B and C and on D. These are all 2 meter. They are all at 2 meter gap. Each are at 12.5 kilometer. So we will obtain the force in each beam. First, the external reactions. Okay. So if we only consider the external reaction, a diagram only for the external reactions. So we assume that A y in positive y direction, A x in the positive x direction, and here also we will not get any ey is equal to 0, otherwise this thing will move. So we will use ex at point E, and point A also there is 12.5 kilometer, and at point B also 12.5 kilometer, point C also 12.5 kilometer. So for if force balance equation in x direction, for all of the trussel it will be ax plus ex is equal to 0, because in the x direction only there is two force, ax and ex. Then at y direction, force balance equation will be ay minus 4 into 12.5 to 0. So ay is equal to 50 kilometer. So to solve ax and ex, to know all the external equation, we need another equation, which is we will get from torque balance equation. Let us calculate the torque at the point of view of A. The pivot point is A. So that will be ex to es, that is at 2.5 direction. 12.5 kilometer at 2 meter distance, which is at point B, minus 12.5 at point C. The point 12.5 kilometer force at point B will not give us any torque. Then we find minus 12.5. So from here, we will definitely get AX from X solution. And also we can use theta. So Px into 2.5 will be 12.5 plus 5 plus 6. So Vx into 1.5 by 2.5. That 60 kilonewton. So if Vx is 60 kilonewton, Ax is minus 60 kilonewton. Now, for the thing, the value of Vx is direction Ay is this direction and Vx this is direction. This is 60 kilonewton. This is minus 60 kilonewton. Ay is at 50 kilonewton. There is another force 0.5 kilonewton. This is all the external forces. The angle we need to know the theta. So we know that is 2.5 and this is 6. So this thing will be 6 square. It's 0.25. This is actually 6.5. So sin theta is 2.5 by 6.5. Is 5 by 13. Cos theta is 6 by 12 by 13. Then can start. This is A, this is C, this is B, this is E, this is F, this is G. So for D, thing is we need to let's go the classification is direct in y direction that will be enough. D in the direction there is a from the direction there is C and the direction B. So from force balance equation in x direction, we need to calculate all the x direction. So 12.5, let us draw. 12.5 will not have any x direction component. CD is only x direction and other component of GD. So here we can see that these are in negative y direction. So minus CD minus GD cos 40 cos theta equal to 0. So CD will be negative GD cos theta, which is minus ZD cos theta will be 12 by 30. We need another equation to solve CD and GD simultaneously. So we need to write force balance equation in y direction also. So here we need to write, so in the y direction, CD will have no component, GD will have component. So 12.5 minus GD sine theta is equal to 0. So from here we will get GD is equal to minus 12.5 by 5 into 30, because sine theta is 5 by 13, which will be minus 32.5 kilonewton. And we know the GD is minus 12.5, that is 5 into 30, 12 by 30, sorry. So this will be kilonewton, 12.5. So this will be a kilonewton. So we have gotten CD and GD from here. Then move to the point G. So from point G we get, where is CD in this direction, GD, and this direction FG. So for the simplicity, we have assumed that this is the y direction, this is the x direction. Even if we don't want to like assume that this angle is theta, similarly this angle is also theta. So if we want to calculate fx, basically give equal to 0 and fg is equal to gd. If we like assume this is y and x, if we don't, then we need to calculate x and y direction. We can see that way also, that this x component is in this direction and x component is this direction. So gd cos theta minus fg cos theta is equal to 0. From that we can get that fg is equal to gd. If we know gd is minus 32.5 kilonewton from here, and from f direction it has a theta. So from y direction, if y is equal to 0, we will get plus ZT sine theta minus f g sine theta equal to 0. If g is equal to gd, so basically they will cancel out. So cd equal to 0. Now, if now we move to point C, then F, then B in that order, and we will know the rest unknown. If we carry on equation for joints C, then F, then B, we will get rest of the thrust force. Now let's move to the next question. And the horizontal and vertical components of force which have been C exerts on member C E of the frame in figure. So the figure is So, input is load here 2000 Newton. This is C. This is 2 meter. And this is 2 meter. So we need to calculate the Cx and Cy. So they have not asked everything what AB is giving, what BC is, um, what is the force for BC. We need to calculate only the horizontal and vertical component of the force which PC exerts on the member CD. So here we need to calculate Cx and Cy. What is the force exerted by the surrounding on the system? So we need to exert Cx and Cy. So we need to only consider that CD because they have asked us the force C exert on the member CD. Okay. So for AB, the point B will feel CD. Here AB is facing compression. So there is what means and this is how so so that CX in negative x direction and let us assume CY is in positive x direction. So there is three unknown. For three unknown equation, we will get for three unknown, we need to write three unknown equation in x direction. Maybe cos 60 degree. So AB will be this because 60 degree and AB y and this is ABX. So AB cos 60 degree minus CX will be 0. From FY we will get AB sin 60 degree plus CY minus 2000 will be 0. So to note CX, we need to know AB, and for CY, we also need to know AB. So we need a torque equation. Let us consider the torque from point C. So 2000 CY and CX will not contribute in the torque. So this will be FAB sin 60 degree into 4. So 2000, we start from the top equation. So 2000 into 2 minus FAB sin 60 degree into 4 is equal to 0. So FAB is equal to 2000 2 by 4 into sin 60 degree. It will be 11,547 Newton. So putting this value on effects, we get CX is equal to 11,547 cos 60 degree, which is 577 Newton. And putting this value in FY, we get CY is equal to 2000 minus 11,547 sin 60 degree, which is 1000 Newton. So here asked to calculate only distance CY and CX. So this is the solution. Now move to the next solution. the compound beam is being supported by a ruler at A and B. There is a hinge in at D. Determine the reactions at the support. So this is this is this is so this is A, this is B. B has also has a record. C only has pinpoint. So there is a force 4 kilonewton A is at 6 meter distance. There is a force at 8 kilometer, which is 4 meter, and this is 2 meter. This is 8 meter, and there is a force here that is 5, 4, 3. The angle is there at force is 1 kilometer. This is at 8 meter, and from this is 8 meter. So Vy has in the y direction. A has Ay in the y direction. So X and Bf is not bounded. So there is a hinge at D determining the reactions at the supports needed the thickness of the beam. So we need to calculate the Ay, By, Dx, Dy, Cy, Cx. All the sorry, there is no Ax, Ay, By, Cx, Cy, Dx, Dy. So basically, equation of equilibrium with and E. For at A, we calculate of E. So that will be equal. So that will be Ay E. Ay is 4 plus 12, 8. We have to. So for this calculation, we have divided the thing. We have divided the section along B. So on the order of the B, we get the equations. With 8 here, and there is 4 kilonewton here. This 6 meter. This is 4 meter. This is and we have the best one here. put all this value, AY is 1.59 kilonewton. If x needs to be equal to 0, which will be x and in fact, we have the letter dy with the calculation and the rate of considering knowledge that is 1.5 minus 4 cos theta is the right on the now we'll put the equation for insulins. What it and blocker B. So for blocker A, we are going to so here D works is D if we moving in positive x direction. So here the force joint force will be in this direction and dy here is it work also and B here is a torque 15 kilo Newton into meter. Here is the term for C, this is Cx, this is Cy. For By, this is By. So for in C, torque is equal to 0. This is Vy into 60 plus 12 into cos theta 4 by 5 plus 1 point plus dy into 24 plus 15 equal to 0. So Py is 8.54 kilonewton. Now we need to move to force balance equation in x direction, which will be equal to 0 plus cx minus dx minus 12 theta. Right force balance equation for y direction, which will be cy plus by minus dy is equal to 0. We know dy minus dy is 1.87 kilonewton, and we have obtained by 8.54 kilonewton. So we'll get the solution here. Yeah. 9.2 kilometer. Also take into account of this force. So 1.87, that is equal to 2.93 kilometer. Last question is question 5. Spring the A to B distance is 0.1 meter. B to C distance is 0.6 meter. And K is equal to 400 Newton per meter. This is theta. This is also theta. This is C. The spring has an unstretched determine the angle theta for equilibrium if the uniform each have so 5 kilo. The length x is equal to 0.6 sine theta. This is basically BC sine theta. Distance and FBD is basically 400 into 2.6 sine theta. 400 is equal to K, basically minus 0.3. So it is, that is a unstretched length. Kx, basically it is force is equal to Kx. So here x is B sine theta, that is B sine theta minus 120. Draw free body diagram for EC. have a force BD, which is 480 sine theta minus 120 5 kg into G. Then it has some Cx and Cy for torque balance equation. Get equal to 0. So Ex will be 0.7 because this is 0.1 and this is equal to 0.6. This will equal to 0.35. So Ex 0.7 sine theta minus FBD, which is the x direction, that is 480 sine theta minus 20 plus 5 9.81 into 0.35 cos theta is equal to 0. So basically Ex is equal to 411.4 cos theta minus 137.4 cot theta. So here basically you need to solve the spring problem. Then you need to consider the whole system. Third step, second step, y, sorry, actually you were in this direction. 5.8, 9.81 is there. 5.9, 9.5 into 9.81 in this direction. So we need to balance is MA to balance 0. So Ex is 9.81 into 2.35 cos theta. Now putting the value Ex here, we get theta is equal to 21.7. I wanted to discuss more problem. But let us see. I think I will have no problem regarding class in next session. Thank you.